Hello, I'm going to give a hopefully brief introduction to z-scores, the normal distribution, and how they work together. Now, all a z-score is a standardized score that tells us how many standard deviations away from the mean a certain raw score is. A raw score is any score that hasn't been manipulated. For instance, my height of 71 inches, I'm 5'11" last I checked. I'll never make it to 6 foot, but that's okay. My height of 71 inches is a raw score. But if I was to compare that score to the average height of American men, my z-score or my standard score or standardized score would be 0.33. I calculated the z-score by making a quick Google search to find that the mean and standard deviation of American men's height is the mean is 70 and the standard deviation is 3. I just typed it in. It might be a little bit different, but just for demonstration purposes, that's what we'll go with. To get the 0.33 I was talking about earlier is we would take our raw score of 71, subtract the population mean of 70, and divide that by the standard deviation of 3, where 1 divided by 3 is 0.33. So here, hopefully you can see my cursor up in the top left of this picture, I suppose you can call it. This is the z-score formula, which is raw score minus population mean divided by population standard deviation. This symbol is a terribly butchered mu symbol, the Greek letter mu. And this symbol I'm pretty proud of, although it's not terribly difficult to draw. This is lowercase sigma in the Greek alphabet. Generally, in statistics, your population values or your population parameters are denoted by Greek letters, whereas sample statistics are denoted by English letters, like the letter X. So in our case, or at least in my case, I did this by, and I'm going to be drawing it, hopefully it updates quick enough. So my z-score of 0.33 was calculated like this. My raw score of 71 inches minus the Googled population mean of American men height in inches divided by the Googled population standard deviation of 3 inches. So if we were to just break that down, this would become 1 divided by 3. And if you have your handy dandy calculator ready, this comes out to 0.33 repeating. But in my experience and in a lot of the books I use, which I'll show later, they have z-scores rounded to 2 decimals, so to the hundredths place. So this is my z-score for my height compared to other American men. It's become standardized so that it can be compared to others. Now that we have a z-score, we can map it onto the normal distribution to see where I compare to the rest of the American population of men according to height. Now, here in the not drawn on portion, so the -3, -2, -1, 0, 1, 2, 3, these are your z-scores mapped onto a normal distribution. All a -3 means is a raw score that is 3 standard deviations below the mean. Underneath, I have written the corresponding raw scores. So a z-score that is 3 standard deviations below the mean, our standard deviation is 3. 3 times 3 is 9. And since it's negative, it's below. Our mean is 70, which I placed here right in the smack dab middle. So 70 minus 3 standard deviations of 3, or 9, is 61. And 3 threes above the mean, or 3 standard deviations that just so happen to be 3, which is 9. 3 times 3 is 9. 9 above the mean is 79. I guess with the 3 threes, that kind of was confusing, but let's say 2 threes. So 2 standard deviations above the mean, which is the same thing as having a z-score of 2, is 76. Keep in mind that even though it is drawn here, this is kind of outside of the scope, but it's always something I like to tell my students. Even though it's drawn here, the normal distribution never actually touches the x-axis. Even though these lines are touching right here, technically the normal distribution is infinite. that never touches the x-axis. But since 99.7% of the data, or 99.7% of scores in a normal distribution, mind you, it has to be normal for this to make sense, or this to be accurate rather, 99.7% of scores in a normal distribution lie between -3 and +3 standard deviations, which is the same to say 99.7% of scores lie between a z-score of -3 and a z-score of +3. It is, however, in the realm of possibility to have a very large z-score in either direction, negative or positive. So since we're measuring human height, or at least American men height, Andre the Giant probably has a z-score of around 12 or 15. I don't know exactly how tall he is. I could have done a Google search, but that's beside the point. Anyway, a bit off topic. Let's circle back to my z-score of 0.33. So -3, -2, -1, 0. This row is for z-scores. And so my z-score is between 0 and 1 at about 0.33. And this 0.33 corresponds to a raw score of 71. In the bottom rows, I've put the raw scores. Every z-score has a corresponding raw score, and every raw score has a corresponding z-score. One thing I love to do, and would suggest anybody do, is not only draw a normal distribution when you're dealing with questions about normality or the normal distribution of z-scores, but also map where your z-score is in particular. And so I'm going to draw a straight line straight up from 0.33. Now, I always suggest, again, drawing a normal distribution. Now, in a normal distribution, let's go back to brushes, z-scores have a corresponding probability. If I wanted to calculate my percentile rank to see what percentage of American men I am taller than, I would look in the appendix sections of one of these fine statistics books that several students over the years have graciously donated to me. My favorite one is this business statistics one, but who likes books that have a 3-ring binder attached? Now, you could go digging in the appendix of a book, or you could just have a handy dandy Z chart sitting right next to you, like in my case. Now, reading this chart tells me that a proportion of 0.1293 or 12.3% lies between, I'll draw a little arrow, let's make it blue. So that Z chart tells me that within this shaded area here between a z-score of 0 and the z-score we just calculated, my height, if you wanted to talk about it in terms of the raw scores, since human height is a normal distribution, we can make this sentence, or make this statement rather. There's a proportion of 0.1293 between 70 inches in height and 71 inches in height. What this is saying is, because human height is a normal distribution, and you could also say the same of American men's height, a proportion of 0.1293 American men are between 70 and 71 inches. This can also be converted to, if you move the decimal proportions to percents are rather simple. This becomes 12.93%. The normal distribution also tells us that, to the shapes line, 50% of scores, oh, I should make that blue. Oh well, I'm not terribly familiar with paint. Normally I just use a whiteboard, but on my other computer, I have the script, I'll admit it. I just don't want to sound too silly. And I can't even draw, we'll just draw an arrow in blue. A normal distribution also tells us that 50% of scores lie below the mean. Lie below a z-score of 0. A z-score of 0 is the same thing as the mean of the raw score distribution. 50% of scores lie below a score of 70. Now, if I wanted to calculate my percentile rank, which again, the percentile rank is the percentage of scores your score or a certain score falls above, meaning I could find out what percentage of American men I'm taller than. So I have a raw score of 71, and I could find out how many men in America am I taller than, or at least what percent. Now, everything to the left, at least in this diagram, or everything below the mean of 70 constitutes 50% of the total scores, or a proportion of 0.50. So if I wanted to calculate my percentile rank, I would add that to the probability I found in this chart here, which gives us the probability between 0 and my z-score of 0.33. So that's going to be, I'll make it a proportion and then convert it to a percentage later. So 0.1293 plus everything to the left of the mean, although if this is mirrored, I might be pointing to your right, but everything to the left of the mean on this diagram, or everything below a mean of 70. And again, the mean has a corresponding z-score of 0 always. When we add this, this comes out to be 0.6293, which is roughly 63%. And the roughly symbol is a wavy equal sign. So this is roughly 63%. So what this means is I am taller than 63% of all other American men. Now, I'm sure you guys have maybe heard, oh, my baby is in the 95th percentile in terms of weight. That means when your baby was born, they were heavier than 95% of all other babies, maybe at the hospital, maybe in America. It depends on where they got that data. So percentile ranks are a lot of fun, and all you really have to do is calculate a z-score, have a chart, or through the power of technology, you could, hopefully it's sharing my whole screen, go to one of my favorite online calculators to find out what percentage of humans or human males in America, I suppose I should say, I am taller than. To do that, we'll set our mean to 0 and 1. The z-score for the mean is always 0, and the z-score for one standard deviation is 1. And since percentile rank is all scores that fall below a certain score, we will hit below, and I have already calculated my z-score of 0.33. Now, this whole calculator here could be a whole lesson on its own, but for brevity's sake, I'll just show you that this indeed is possible. And lo and behold, this 0.6293 looks an awful lot like this 0.6293. So according to both my math done by hand and this handy dandy online calculator, I am taller than 63% of American men. Thank you so much for taking the time to watch this. Normally I do a lot of this off script, but again, I wanted to at least not, in fact, the whole last paragraph I just ad-libbed, but with statistics, and there's not a lot of off script you can actually do, just some of the weird jokes I guess I put in here. I might have skipped over, but thanks again. And I'm actually very interested in having this tutoring opportunity come to light. So thank you guys for watching, and hopefully the whole video worked out quite well. I'm still new when it comes to recording on Zoom. I do most of my sessions on Zoom anyways. I have an official Boise State account. Anyways, I'm talking too much. Thank you.